Here we go with Systems 2.3. So the first one's determining points that satisfy equations and solve systems of equations. 3 points are given. Each point is a solution to at least one of the equations. Find the point that satisfies both equations. This is a solution to the system. Justify that point is a solution to both equations and the others are not. So basically we've got to take these x and y values, plug them into both equations, see which ones work for both, which ones don't work. So we'll start with A. So y value of 5. So 5 equals 2 times negative 2 for x minus 3. And then 5 equals negative 2, because it's negative x, so you have to have that negative outside, plus 3. Okay, so 2 times negative 2 is negative 4, minus 3 is negative 7. That one does not equal, so it doesn't work for the first one. Okay, so I know already that A is not going to work. I don't have to do the next part. I could get positive 4, or positive 2 plus 3 equals 5. So it's a solution to that equation, but not to this one. So therefore it's not a solution to both of them. Okay, so now we take this, erase the x and the y, and plug in our next x and y. So y of 1, x of 2. Negative 2 plus 3 gives us 1. Does 1 equal 1? Yes. So it works for that one. 2 times 2 is 4, minus 3 is 1. 1 does equal 1. So there's our solution for both of these, which means C isn't going to work. Okay, which means we have to show which one it doesn't work in, because it wants us to justify that that's our only answer. So y value of 5, x value of 4. 2 times 4 is 8, minus 3 is 5, so it works for the first equation. Negative 4 plus 3 is negative 1. There we go. Doesn't work for that one. Okay, so our answer would be B. So that's all we do on these guys, is we just take our y value and we plug in what we're given, and we solve. So let's start with A. So y value of 0, x value of negative 1. Negative 1 is 1. 1 plus 3 is 4. Doesn't work on that one. Okay, negative 3 plus 3 is 0, so it does work on the first, not on the second. So we know A is out. Okay, so now we do the same process for this one, for B. So negative 3 for y, 6 for x. Negative 6 plus 3 is negative 3, so it checks out for this one. Okay, 18 plus 3 is 21. Okay, definitely doesn't work for the first one. So that's out. So most likely our answer is C, but we've got to double check to make sure that it works. So let's erase these. Okay, 3 for y, 0 for x. 3 times 0 is 0. 0 plus 3 is 3. Works on the first. Negative 0 is still 0. 0 plus 3 means it still works for the second. So there's our answer. So that's all we do on these ones. So y equals 2 just means we can really only put in the y value. Okay, so we start with A. 2 for y, so it works on the first one, right, which C has a y value of 2. Because there's no x, our x's don't really matter. So I know for the first one, A and C both work. Okay, what about A on the second one? So that would be equal to, that would be 7. Negative 4 times 7, negative 28, minus 6, negative 34. Definitely doesn't work. Okay, now we try B. 2 and negative 14 definitely doesn't work. Okay, 2 and negative 14. Negative 4 times 2 is negative 8 minus 16, negative 14. So B does work on the second one, but not on the first one. So let's see if C works. Okay, we already know C is going to work for this one. So what about this? So 2 and negative 2. Negative 4 times negative 2 is positive 8 minus 6 is 2. So yes, C works. That's the one that works for both. There's our answer. So clear some space out. Take a look at number 4. Same idea. So y equals 2x plus 4 and x plus y equals negative 5. Now we've got a standard equation that we're throwing in here, but it still works the same way. 1 for x, 6 for y, 1 for x, 6 for y. 2 times 1 is 2 plus 4 does equal 6. So on the first one, A works. 1 plus 6 is 7, does not equal negative 5. On the second one, it doesn't work. So we know that that's not our answer. So let's see about the next one. B, negative 3 for x, negative 2 for y. I can see right there, add those together, negative 5 does equal 5. So on the second one, it works. What about on the first one? Negative 3 for x, negative 2 for y. 2 times negative 3 is negative 6, plus 4 is negative 2. Yep, it works on the first one. Now most likely that's going to be our answer, but we do need to double check to see if the first one would work. Negative 3 for x, positive 2 for y, add those together, you get negative 1. We definitely know it's not going to work on the second one. Does it work on the first one? 2 and negative 3 would be negative 12, negative 8. It doesn't work for either of them. So that's our answer. Alright, the set. Create equations, solving real-world problems, solve systems of equations. So a phone company offers a choice of 3 text messaging plans. Plan A gives you unlimited text messages for $10 a month. Plan B gives you 60 text messages for $5 a month and then charges you 5 cents for each additional message. And Plan C has no monthly fee but charges you 10 cents per message. Write an equation for the monthly cost of each of the 3 plans. So Plan A, that was a horrible A. So Plan A, so unlimited text messages for $10 a month. Okay, so what's the connection here? What would be our variables? Y might be the cost of our plan. X would be the number of texts. Okay. Now, if we look at the first one, does it matter the number of texts? No. Your cost is always going to be $10 a month. So Y equals 10. Okay, B. 60 text messages for $5 a month and then charges you 0.05 for each additional message. Okay, so how would we write this one? So our cost is equal to, it's 0.05 times the number of messages plus the $5. Now that $5 stands for 60 texts. So that X is after we get past 60. Okay, after we get past 60. So that's important. So how would we, is there a way we can make that work with these other ones? Okay, how would we get that to work? And it seems a bit strange and you probably can't come up with it, but it would actually have to look something like this. Okay, remember that x minus 1 or n minus 1 that we've dealt with? We'd have to say, okay, we're going to subtract 60 from the number of texts, and that's going to give us a more accurate reading. Now, we could simplify this and try to work it through like that and see where we'd end up, and that would give us a more accurate way of thinking. And so we'd end up with y equals 0.05x minus 3, because 0.05 times 60 is 3 plus 5. So you'd end up with 0.05x plus 2 would be your more accurate way of doing that. Then that way you wouldn't have to worry about the thing. So either one of those would work. I prefer this one. Okay. So now C says no monthly fee but charges you 10 cents per message. So that would be y equals 0.10 times x. No plussing. Okay. So then it says if you send 30 messages per month, which plan is cheapest? Well, plan A is going to be $10, right? Plan B, because that's less than 60, it's going to be $5. Plan C, well, what's 0.10 times 30? That's 3. So plan C would be the cheapest, right? What is the cost of each of the 3 message plans if you send 50? So it's still 10 for A, still 5 for B. Okay, but at 50, C would also be 5. So it would be either B or C. So determine the values for which each plan is the cheapest. Okay, so in other words, how many messages do we have to do to make one more expensive than the other? Well, to get B above $5, we're going to have more than 60, right? If we have more than 60, we're definitely above the $5. C is a tenth of whatever we're doing, so at 60, it would be $6. At 70, it would be $7. So for plan C, to get over $10, you're going to have to go more than 100 texts. Okay, would make C more expensive. Well, at 61 texts, B would be $5.05, right? So a way to think about it is, if I have 5 cents, I'd have to send 5 cents a piece. I'd have to send 100 texts to get it to be another $5. So 100 texts would give me $5 plus $5, so it would give us $10, so it would be the same A. So for A to be the cheapest, you're going to have to send over 100 texts, which I'm sure a lot of you already do way more than that, so that's not a big deal. Okay, so for A to be the cheapest, you'd have to go over 100 texts, so more than 100 texts. For B to be the cheapest, okay, you would have to go between 60 and 100, right? Something around there. And for C, it would be 30 we found, so it would be less than 50. You get UC to be the cheapest. Now you could take those equations and graph them all on a coordinate plane and see where they're all equal, and therefore see when some are cheaper than others. And maybe they wouldn't all be equal. Okay, so you could do that, and if you did that, this is what it would look like. So using Desmos, I've got our equations here. So red is y equals 10, right? And we can see some points of interest. Notice they don't all intersect at the same place. Okay, so in order for green to be the cheapest, like we said, from 0 texts up to 40, that's when that's going to be the cheapest. So 0 is less than x is less than 40. Okay? I suppose we could say less than or equal to. Okay, number 2, the blue line. Okay, so right here at 40, it becomes the cheapest, right? Okay, and if we were able to follow the graph, we see until we get to 160, that's when it intersects with the $10. So from 40 to 160 is when that one's the cheapest. So 40 is less than x is less than 160. This is how you'd write it. Okay, and then beyond 160, that's when the red So x would be greater than 160 for that one to work. Okay, so kind of a cool way of seeing it with those graphs. And that was using that Desmos calculator, graphing calculator. And notice I was able to write in our equations just how they looked, graph them, and see those intersection points. Pretty good, useful tool for checking your answers. Okay, now on the next ones, we're just taking these relationships and writing them in different ways. So, days and cost. So create a context or story. So, let's graph it first. That's probably the easiest. So we go up to 32, so I maybe want to count by more than just one, because my graph doesn't go up that high. 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe count by 4s. So that'd be 4, 8, 12, 16, 20, 24, 28, 32, 36. So 1, 8, put us right here. 2, 16, right here. 3, 24, and 4, 32. Okay, and we probably would want to go back to 0. We can see that we're adding 8 each time, right? So it'd be 0, 0. So there's my graph. If I wanted to, I can continue it that way. You don't have to. So our equation would be y equals, we started at 0, because that's where 0 was, and then we're adding 8 multiple times. So we could simplify that to simply y equals 8x. You could also do the recursive and go f of x equals f of x minus 1 plus 8, and f of 0 equals 0. Either one of those would work. So it's something to start at 0, and every day our cost was $8. So maybe you'd say something like, Bill had his buddy do his math homework and every day he paid him $8 to do it. Okay, something about that cost for somebody being $8 every day. Alright. Okay, the next one. Okay, so Claire earns $9 per week allowance. So weeks, probably how much she's earned. So at 0 weeks, she hasn't earned any. At 1 week, she's earned 9. At 2, 18. At 3, 27. And so on. So we're adding 9 each time. So we could go y equals 9x plus 0, which we'd leave the 0 off, or f of x equals f of x minus 1 plus 9, and f of 0 equals 0. And we could graph it, maybe we just count by 9s, 9, 18, 27. So our graph would look like this if we counted by 9s. If you didn't count by 9s, it would be a little bit steeper. Okay? Alright, 11. Y equals 3x. So x, y. So at 0, we'd have 0. At 1, we'd have 3. At 2, we'd have 6. At 3, we'd have 9. So 0, 0, 1, 1, 2, 3, 2, 6, 3, 9. So our graph would look like that. Crazy context. Horatio kills 9 zombies every day. And I know you can't read my handwriting, that's what I have to listen to. Alright, so now this one we've got a graph, so let's plot the points. So at 0, we're at 9. At 1, we're at 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 2, 7, 3, 6, so on. So we're subtracting 1 each time. So y equals, we started at 9, we subtracted 1 multiple times. You could rewrite that as y equals negative 1x plus 9, or even y equals negative x plus 9. If we did recursive, f of x equals f of x minus 1, and f of 0 equals 9. In the context, Jenny has she have? She has 9 fingers, and every day she cuts one off. Something like that. Alright, number 13. Tickets to a show cost $10 in advance and $15 at the door. If 120 tickets are sold for a total of $1,390, how many of the tickets were bought in advance? So we need to make some equations here. So let's say A is for the advance tickets, and we'll say D is for at the door. So I know 120 tickets, so if I add my advance tickets and my at the door tickets, it's 120. Now if I want to find the price, I would multiply those advance tickets by 10 and the at the door by 15 to get me $13.90. Okay, now I need to graph these, right? So we need to put them in a format that's easy to graph. So let's say D is like our Y and A is like our X. So I'd subtract A. So I'd have D equals negative A plus 120. Okay, then I'd subtract 10A to get 15D equals negative 10A minus 1390. Then we divide everything by 15. So we get D equals 10 and 15 would give us negative 2/3 A minus what's 1390. We get 92 and 2/3. Okay, so that's ugly. So this is where you'd want to use Desmos to help you out. So once again, this is where you'd want to have an equation help you out. So if we look at this, graphing both our equations, we can see that's where our answer is. So that's like the X or the A. That's the Y value or the D. So we sold 82 tickets in advance, 38